Quadratic expression is factorable. Okay, so prime polynomial is what happens when it cannot be factored using integers. Okay, so if you were to factor it somehow, you'd be getting decimals and or fractions. So we don't really factor these because there are so many different combinations of decimals and fractions. There's infinite numbers of them. We can't try them all and find the factors. So if you can't factor it using integers, it's called a prime polynomial, and for all intents and purposes, it is essentially unfactorable. Okay, so we're going to try to factor these, and then if we can, we factor them, and if we can't, we say they're prime. All right? Now, don't fall into the trap of looking at it and going, oh, I don't know what the numbers are, it's prime. No. You have to actually try. I know, I'm so mean. So we have 4 times 5 is 20. So I'm now going to look for factors of 20 that will give me a negative 3. Now, my 20 is positive and my 3 is negative, which means I need a negative here and a negative here. So 2 negative numbers that multiply to make 20 but add to make 3. Right? Because 20s are 4 and 5, 2 and 10, 1 and 20. None of those add up to make 3, do they? Okay, so in this case, we have nothing to put here, so this one is prime. And it does get kind of, it's almost that, like it's pretty obvious, usually, you know. 4 times 7 is 28. Again, I have a positive 28 and a negative 1. So I'm looking for 2 negatives because I have to multiply to make a positive. So I'm looking for 2 factors of 28 that will add up to 1. There aren't any, are there? Right? There's nothing I can put here and nothing I can put here. So this is prime. Okay, if I try this one, I have 2 times negative 5, which gives me a negative 10. Wow, that's not how you write negative 10. Yeah. Okay, so I'm looking for a negative 10 and a positive 3. So a positive and a negative number that'll multiply to make 10 and have a difference of 3. What multiplies to make 10? 5 and the difference between 5 and 2 is? So which one do I want to be positive? 5 and then the 2 negative. So this one can be factored. Oops. So I'm going to put the 2 with the 2 because they match, right? So I'm going to put minus 2x plus 5x minus 5. Because 2 and 2 match and 5 and 5 match, and I like it because they're matchy-matchy, and that's good. I can factor a 2 and an x out of here, and I'm left with x and a negative 1. And I can factor a 5 out of there, and I'm left with x and a negative 1. So x minus 1 and 2x plus 5. Yeah, matchy-matchy, good in math, bad in couples. Okay, so suppose there's a cheetah, and it's pouncing on an antelope. And it leaps with an initial velocity of 19 feet per second. So that's its speed, is 19 feet per second. And we want to know how long is the cheetah in the air if it lands on the antelope's hindquarters 3 feet off the ground. So here's what's happening. You've got a cheetah, right? And you've got an antelope. And the cheetah jumps up here. Okay, this is a parabolic curve. So if the antelope was not in the way, like if the cheetah misses the antelope, the curve continues in like a perfect arc. Okay, and those can be modeled with math. All right, this distance right here is 3 feet. The initial height that the cheetah jumps from is 0 feet because they're jumping from the ground, right? Okay, so The model for the height of a projectile, so projectile motion, that's what this is. And so it is a projectile because the cheetah projects themselves. And this is the model for pretty much any projectile, is that the height is equal to -16 times the time squared plus the initial velocity times the time plus the initial height. And that works for jumping cheetahs or throwing a ball. Yeah, throwing a ball or anything. Pretty much, yeah. Yeah, there's a couple that are a little bit more complicated for different, like that'll take into account like wind resistance and stuff. But this is the basic formula which ignores wind resistance and things like that. So, yeah, of course. So, is my beautiful antelope? Yeah, thanks. Okay, so t is the time in seconds, and what we're trying to find is how long is the cheetah in the air, right? So that's what we're solving for. How long is the cheetah in the air? We're looking for t. Okay, so if we do that, we have h is equal to -16t squared. And we have the initial velocity. Our initial velocity is 19, because it was 19 feet per second. So plus 19t plus HO is the initial height. Okay, so my initial height is 0. But the height where you land, this is the land, like the height, this is going to be 3. So we're going to take this out and put 3 in, because this is the hindquarters where your height, the highest part you're reaching is the hindquarters, because they're jumping up on the hindquarters. So I have to set it equal to 0 first. So in order to do that, I'm going to subtract that 3 from both sides. And so I get 0 is equal to -16t squared plus 19t minus 3. And I don't like all these negatives in here. So what I'm going to do is I am actually going to rearrange. To make that t squared positive, just because that way it's going to be easier to deal with. And so essentially what I'm going to do is I'm going to change all the signs. So I've changed all the signs. And I flipped it around the equal sign because I like my t squareds better over here, because I'm just, that's the side I like them on. They don't have to be on that side, I just think it's prettier. And of course the sign on the 0 didn't change because 0 doesn't have a sign. Okay. So now I have 16t squared minus 19t plus 3. So my next step is going to be to factor my quadratic. So I'm going to do that over here. I'm going to do 16 times 3, which is 48. And then I'm going to look for two numbers that will multiply to make a 48, but add to make a -19. If they're giving me a positive 48, but adding up to a negative, I know they're both negative. Okay? So, things that will multiply to make 48. Well, I know 16 and 3, right? And luckily those just happen to add up to 19, so I've got -16 and -3. So I'm going to replace my -19 with -16 minus 3. I'm going to factor this out. I can take a 16t from both of these. I'm left with t minus 1. And I'm going to go ahead and take the -3 out here to get the t minus 1. And I get 16t minus 3 and t minus 1. My next step is to split and set both equal to 0, and then solve. And I'm out of room, so I'm going to do another blank sheet. So, okay, so I split each of those and set them equal to 0, and then I solve them. So I'm going to add 3 to both sides, and I get 16t equals 3, and I divide by 16, and I get t is equal to 3/16, and I add 1 to both sides, and I get t equals 1. Now, to determine which one of these is the correct answer, okay, we have to sort of analyze the picture. Okay, so remember we have a cheetah, and we have an antelope. Okay, and the cheetah jumps up onto the antelope. Now, do you think that this is what happens? So here's the cheetah, here's the antelope. Do you think it's a straight here, and the cheetah would still be going up if he didn't hit the antelope and then come down later? Or do you think the cheetah goes up a bit and then comes down on the antelope? The second one, right? The cheetah probably goes up and then lands on the antelope, correct? Do you guys agree with that assessment? Well, that means that the cheetah is at a height of 3 feet in 2 places, here and here. That's why we have the 2 answers. This is 3/16 of a second. This is 1 second. Because he's moving through time as he's moving through air. So he's actually in the air for the full 1 second. So my answer is 1 second. Let's try another one. A person throws a ball upward from a building. Here's your building that is 506 feet. And there's a person on top, and he throws a ball. Okay. Here's the equation for the ball's height, and then the ball lands on a balcony. So upward, it went more like this, right? The ball comes down and it lands on a balcony at 216 or 18 feet from the ground. So here's your balcony. Okay, so let me move the building height. Oh, too big. So the building is 506 feet. The balcony is 218 feet. So we want to find out how long was it in the air. Our height here matches the height of our balcony. So we have 218 is equal to negative 16t squared plus 48t plus 506. Our initial height is 506 because the person was standing up on top of the building. And then the 48 is actually how fast the ball was moving. Okay, so I need to first set this equal to 0, so I'm going to take 218 from both sides. And I'm going to get 0 is equal to negative 16t squared plus 48t plus whatever 506 minus 218 is. You guys have those memorized, right? Your 506s? No? Okay. 288. And I don't like the negative 16t. So this was set equal to 0. Then I'm going to change all the signs. And again, I like to rearrange it at this point and put my stuff on this side. So the negative becomes a positive and the positives become negatives. Then I factor. And to factor this, I need a big giant X over here. But first I need to find out what is 16 times negative 288. Come on, you guys have your 288s memorized, right? It is negative 4608. All right, so I am going to look for a number that when I multiply it, I get negative 4608. And when I add them, I get negative 48. Go. No? All right. We're going to hold this aside for a second, and we're going to use this space down here to make our factor tree of 4608 and then determine what we can combine to get that difference. Okay, so it ends in 8, so I'm going to start with a 2, which ends in 4, so I'm going to keep going by 2. And then I'm going to get 5, 7, 6, 576. So 288. Huh? No, no. Oh, no. Sorry, that was supposed to be 2 and 576. I wrote down that it's supposed to be like that. Yeah. Okay. And then 576 is 2 times 288. And then 288 is 2 times 144, which is 2 times 72, which is 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. Lots of 2's. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. Let me double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So I have 9 2's and 2 3's. So I'm going to try to figure out a 48 out of that. Right? Okay, well 2 3's is 9. Yeah. And 9 2's would be 2 to the 9th, which is 512. And the difference between 512 and 9 is not 48. So I'm going to try, I'm just going to start doing powers of 2, sort of halfway in between. I'm going to do 2 to the 5th. So 2 to the 5th is 32, which leaves me 2 to the 4th because I had 9, so that leaves me 4 left. And 2 to the 4th is 16. And 16 times 9, which would be my 2 3's, right, is 144. And the difference between 144 and 32 is not 48. So this is too far apart still. So what if I do 2 to the 6th? That's 64, which leaves me 2 to the 3rd, which is 8 times 9, which is 72. And that's too close together, because the difference between 72 and 64 is 8. So first I was too far apart, and now I'm too close together. And all I did was move a 2 over this way. So that makes me think that it's not the 2's I need to be moving around, it's the 3's. Do you see what I mean? Yes? No? Yeah? Okay. So I had 2 to the 5th and 2 to the 4th times the 3's. I'm going to move this, and I'm going to put 2 to the 5th times 3 and 2 to the 4th times 3 and see what happens. That gives me my 9 2's and my 2 3's, and my 3's have been split. So 2 to the 5th again was 32 times 3 is 96, and 2 to the 4th is 16 times 3, which is 48, and 96 minus 48 happens to be 48. So I want a negative 96 and a positive 48. And I'm going to replace the negative 48 with a positive 48, right? Because I'm going to put the positives together, and then a negative 96 and a negative 288. And that equals 0. And I'm going to pull out the 16t here, and I'm going to be left with a t and a 3. Because 16 times 3 is 48. That tells me that 288 should divide by 96 and make a 3, and it does. So I'm going to pull out a negative 96, and that'll give me t plus 3. And then that gives me 16t minus 96 times t plus 3 equals 0. So 16t minus 96 equals 0. T plus 3 equals 0. Add 96 to both sides. And I get 16t equals 96. And that divides evenly. So divide by 16, divide by 16. And I get that t equals 6. And if I come over here, I subtract 3 from both sides. And I get t equals negative 3. And we're talking about time. And since we have not invented time travel into the past, can time be negative?
Just like distance.
Right, it's just like distance. We can't move backwards in time, just like we can't have negative distance. So it cannot be negative 3 seconds. Because somebody threw the ball, and then it landed on the balcony. So time had to have passed, so it has to be 6 seconds. So time and distance are always positive. And these are good ways to check yourself. If you get a negative answer on there and you're solving for time, you can't have negative time yet because we have not invented time machines. Maybe someday in the future we'll, once people have figured out time travel, you can solve for negative time. But for now, well, probably, yeah. Section 5 is differences of squares. These are nice. Okay? What we do is a difference of squares occurs. Do you remember when we had the a plus b times the a minus b, and that gave us a squared minus b squared? In the review stuff on multiplying together? Okay. Well, this creates a difference of squares. You have a perfect square minus a perfect square. So a difference of square occurs if you have a perfect square. So this is perfect square number 1 minus perfect square number 2. Okay, and it equals the square root minus the square root. So let me figure out how to write that small enough. This is the square root of number 1 minus the square root of number 2 times the square root of 1 plus the square root of 2. And I just can't write it this way. It's not going to fit. So let me do it this way. Sorry. Okay, I have a perfect square minus a perfect square, and what I get is a plus b, a minus b. So a being the square root of a squared, and b being the square root of b squared. And the way we want to do that is first we look at the two terms. So we have two terms. So step 1 is we identify that it's two terms. Step 2 is we see if there's a GCF. Okay, once we've seen if there's a GCF that exists to factor it out, we factor it out. Step 3 is to see if each term is a perfect square. Okay, So let's go to our first one. I have a 16 and a 9. Can anything factor out of both 16 and 9? Okay, so 16 is divided by 2 and 4 and 8. 9 is divided by 3, so they have no GCF. I have 16h squared, and I have 9a squared. 16, perfect square. 4 times 4, right? 9, perfect square. It's 3 times 3. So I have 2 perfect squares. Awesome. So after I've done that, I do the square root of the first plus and minus the square root of the second. Okay, so the square root of 16h squared is 16h. And the square root of 9a squared is 3a. So factoring this, I do 16h plus 3a and 16h minus 3a. That's what I meant. Thank you. Huh? Too big. Yes, I did. I meant 4. Getting ahead of myself or behind myself, or I'm confusing myself, and I don't mean to confuse you guys. Oh, no. Okay, so 121 and 4 don't have anything in common. So I look, is 121 a perfect square? Yeah, 121 is 11 times 11. And 4 is 2 times 2, so these are both perfect squares. So I take the square root of 121 is 11, and the square root of 4b squared is 2b. So to factor this, I do 11 plus 2b, 11 minus 2b. Always plus and minus. The squares go away because if we were to multiply this back together, and here's your check, right? To check, you FOIL it back out. So if I did 11 times 11, I'll get 121, and then I'll get minus 22b and plus 22b and minus 4b squared. And those two cancel each other out, so I get 121 minus 4b squared. So to check yourself, you just always FOIL them back together, and if you got what you started with, you factored it correctly. 27g to the third and 3g. These are not perfect squares, but remember our first step is to see if there's a GCF. If I look at this, these will both divide by 3 and g. So if I take a 3g out, 27 divided by 3 is 9. There were 3g's. That's a q. I say a g, I draw a q. That's terrible. 3g. Okay, there were 3g's. I took one away, so there's 2 left. And if I take 3g away from 3g, it leaves me a 1. 9 is a perfect square. 1 is a perfect square. And then g squared, of course, is a square, so it's a perfect square. So the square root of 9g squared is 3g. Square root of 1 is 1. So to factor this, I get 3g, because this doesn't go away, times 3g plus 1, 3g minus 1. So whatever you factored out, you just bring it down. It doesn't disappear. Okay. Here I have 6g squared and h squared. 6 is not a perfect square, is it? So this is prime. I can't factor it. 81 and c squared, the square root of 81 is 9. So that is a perfect square. So I have 9 plus c, 9 minus c. This one looks a little tricky because you say, oh, it's got to be a minus. Oh, yeah, this has to be a minus in the middle, minus. But here I have my negative out front, so I have to rearrange first. and then check it. So I put the 9y minus 4y to the third. Well, 9 and 4 are perfect squares, but y and y to the third aren't. But my GCF in this case is y, so I'm going to factor that out. So once I take the y away, I get a 9 and a 4y squared, which are perfect squares. And the square root of 9 is 3. The square root of 4y squared is 2y. So I get 3 plus 2y and 3 minus 2y. And that y that I factored out just hangs out in the front. And GCF of x on this one, so I'm going to factor the x out. And this is almost exactly what I just did. So I have 3x plus 2, 3x minus 2. All even exponents are perfect squares. So if I have x squared, the square root is x. If I have x to the fourth, x squared. If I have x to the sixth, x to the third. So to take the square root of any even exponent, divide by 2. So if I asked you to take the square root of x to the 212th, I'm going to take 212 and divide it by 2, and I'm going to get 106. So that's the square root. So all even exponents are perfect squares. Odd exponents are not, but even exponents are. We have to apply a technique more than once. Okay, so let's look at this. B to the fourth is an even exponent. That makes it a perfect square. 16 is a perfect square. So I do b squared plus 4, b squared minus 4, and then I go, okay, wait a minute, perfect square, perfect square. So I have to do that again. So I get b squared plus 4, that stays the same. And then b plus 2 and b minus 2. Because the square root of 4 is 2. The plus is I can't do this again because this is not a difference of squares. So that one stays how it is. But the minus gave me 2 more perfect squares, so I had to factor it as well. So these stayed the same, and this was factored. Okay, 625 and x to the fourth. I know this is a perfect square. I have this one memorized, but if you didn't, just plug it into your calculator and hit square root, and if it gives you an even number, you know it's a perfect square. Well, it's going to happen to give me 25. And the square root of x to the fourth is x squared, so I'm going to have 25 plus x squared and 25 minus x squared, and I have another set of perfect squares. So I carry the 25 plus x squared over, because that doesn't change. And then I factor these, and I do 5 plus x and 5 minus x. Because the square root of 25 is 5. And then I have the square root of 81 to be 9, and x to the fourth to be x squared. So I get 9 plus x squared, 9 minus x squared, perfect squares again. Perfect square. Okay. So after you factor, here's a really extreme example of like lots of factoring. So okay, so first I'm going to do 1024 divided by 2, and I get 512. Plus 1, minus 1. Perfect squares again. So I divide that by 2. And I get 256. Plus 1, minus 1, which, again, even, divisible by 2. And I have to keep writing down all of my pluses because those don't factor. But I divide 256 by 2 and I get 128. Divisible by 2. Divide that by 2 and I get 64. Divisible by 2. Divisible by 2. And if I divide 32 by 2, I get 16, which is still even, right? And if I divide that by 2, I get 8. And if I divide that by 2, I get 4. And if I divide that by 2, I get 2. And then I finally get 1.
There's a few.
Just a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factors for just this. So that's an extreme example. I won't give you that on like as a test question or as a homework question.